The 13th question says that find the points at which the function f given by fx equals this. What is this value? F of x equals x minus 2 whole power 4 times x plus 1 whole power 3 has local maxima, local minima, or a point of inflection. Let's talk about these things over here. Now fx is equal to x minus 2 whole power 4 x plus 1 whole power 3. Okay, and f prime x is equal to what? This is equal to derivative, and we can find the derivative by product rule and then the, let us say, chain rule. So x minus 2 whole power 4 remains as it is. Derivative of this will be 3 times x plus 1 whole square times 1. Derivative of x plus 1 is 1. Okay, plus the other term, what will that be? This is 4 times x minus 2 power 3, and derivative of x minus 2 is 1 times x plus 1 whole power 3 as it is, right? This is what you'll get. Okay, you can take out some terms common. X minus 2 whole power 3, x plus 1 whole power 2 can come out common. Whole power 3, x plus 1 whole square will come out common, and what will remain is 3 times x minus 2 over there, yes, and 4 times x plus 1 over here. This is what will remain over here in the brackets, right? Once you are through with this, then let's simplify this bracket over here. This is x minus 2 power 3, this is x plus 1 power 2, and this is 3x plus 4x, 7x minus x plus 4 minus 2 is what we have, right? Let's analyze the sign scheme of f prime x. Okay, so critical points will be minus 1, 2 and 2 by 7. Minus 1, 2 and you have 2 by 7 over here as well, right? So this is the critical point, and what will be the sign of f prime x? Please observe, beyond 2 this will be positive, this will be positive, this will also be positive, so overall will be positive. Before 2, between this region you have, let us say, 1. So for 1 this is negative, negative power 3 is also negative, this is positive, so overall will be negative. Between these two, let's pick up 0 for example. This is negative power 3, which is negative, this is positive, and this is also negative, so negative, negative will be positive over here. And what else? For minus 1, what you'll have is, okay, before minus 1 you will have, let us say, pick up minus 2. Negative, negative power 3 is also negative, this is negative power 2, which is squared, right? So what you'll get is a positive over here, negative, negative and a positive, this will be positive overall, right? So function is increasing and then again increasing. The derivative is 0 and the function is increasing before and after as well. Okay, the function is decreasing and increasing over here. So first, points at which the function given by this has local maxima. For local maxima, what do you think are the points? Right, for maxima you'll get this kind of a peak, that is at x equals 2 by 7. And you can also find the value f of 2 by 7 easily. F of 2 by 7 will be equal to what? This will be equal to 2 by 7 minus 2 power 4. What is that? 2 minus 14 is minus 12 by 7. 12 power 4, 7 power 4 times 2 by 7 plus 1 is 9 by 7 power 3. This is 9 power 3, 7 power 3. Okay, this simplifies to what we can see is this is 4 power 4, 3 power 4. This is 3 power 6. So 3 power 10 is what I get. And 4 power 4 will become 2 power 8 over 7 power 7 is the value, right? This is the value of this local maxima, right? The point will be 2 by 7 comma this. What else? For local minima, what do you think? Will there be any point of local minima? Yes, I see one particular point of local minima over here. This is at x equals 2. And can I find the value of this? Yes, f of 2 will be equal to, please observe, 2 minus 2 whole power 4 is 0. So this is simply 0, therefore the point will be 2 comma 0, right? What about point of inflection? Do we have point of inflection as well? Observe carefully. Point of inflection says that the derivative equals 0 at that point, but derivative will not change sign at that point. Derivative will be positive and positive throughout, or negative and negative both sides. So this, yes, x equals minus 1 is the point of inflection. What was the value of y coordinate at this point? F of minus 1 will be equal to, again, this bracket becomes 0, everything will become 0. This is the point of inflection that you will have at minus 1 comma 0, right? That's the final answer for this 13th question over here. The 14th question says that find the absolute maximum and minimum values of the function f given by fx equals cos square x plus sin x. How will we deal with this function? Let's take the derivative. f prime x is equal to 2 cos x. The derivative of cos x is minus sin x, plus the derivative of sin x is simply cos x. Okay. Can we take out something common? Yes, cos x will come out common, and what you're remaining left with is 1 minus 2 sin x. Actually, this term minus this term over here. Okay. And if this derivative equals 0, this tells me that either cos x equals 0 or 1 minus 2 sin x equals 0. That tells me sin x equals 1 by 2. Okay. Cos x equals 0 in this interval will tell me that x equals simply pi by 2. What happens for sin x equals 1 by 2? If sin x is equal to 1 by 2, x will be equal to, in the first quadrant and second quadrant, there will be two possible values of x. X will be equal to, one of the values is pi by 6, the other value is pi minus pi by 6, which is 5 pi by 6. Okay, so these are the critical points over here. Yes, I have pi by 2, I have pi by 6, I have 5 pi by 6 as well. And obviously the end points 0 and pi are also important over here, right? And these critical points are important because the absolute maximum and absolute minimum values will occur at these points only. So let's find the values. F of 0 is cos square 0, cos 0 is 1. This is 1 square plus sin 0, which is 0. This is 1. What is f of pi by 6? Let's find that value. F of pi by 6, cos of pi by 6 is what we are interested in. Cos pi by 6 is root 3 by 2, and you square it, this becomes root 3 by 2 and it's a square, plus sin pi by 6. What is that? 1 by 2. This becomes 3 by 4 plus 1 plus 2 by 4, right? Plus 1 by 2 by 4 is 5 by 4. This is what you'll get. F of pi by 2, what is that equal to? So f of pi by 2 is equal to cos pi by 2, which is 0. This is 0 square plus sin pi by 2, which is 1. This is overall 1. What about f of 5 pi by 6? This is equal to what? Cos of 5 pi by 6. That is minus of root 3 by 2. But you have a square plus sin 5 pi by 6 is 1 by 2, and this again becomes this 5 by 4 over here. What about f of pi? F of pi is equal to what? Cos pi, that is minus 1, and its a square is this, plus sin pi is 0, this is equal to 1. Okay. So you get minimum 1. This is the minimum value, right? So absolute minimum value is 1, and the absolute maximum value out of these you can clearly observe is 5 by 4, which occurs at this point. Similarly, minimum occurs at these few points over here. That's the complete solution and the final answer of this question, as you can see behind me. The 15th question says that show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is this. Okay, so we are talking about a sphere, and in a sphere we are talking about right circular cone having maximum volume. Okay, so this is the right circular cone, let us say, in the sphere. This is what you have. This is the center of this is the radius of the right circular cone, this is the height, and this here is the center of the sphere. This is capital R, let us say this is again capital R, and if this is the height of the right circular cone, I can easily get this distance over here. This is 90 degree. So I can easily get a relation between this h minus capital R and small r. This triangle is a right angle triangle, right? Show that the altitude of the right circular cone of maximum volume of cone has to be maximized. Okay, that can be inscribed in a sphere of radius r. Okay, the radius of the sphere is given as small r. That's pretty interesting. We have taken this radius to be capital R. Let's change that. Let's change those things. Okay, and what do we have? This is small r, and let's take this radius as x for that matter, right? Okay, and to prove, what are we supposed to prove? That altitude of the right circular cone h is equal to 4r by 3. This is what the person says, right? Volume is maximum. Okay, we have solved a similar question in the exercises before this, and we can handle this one as well, right? So what do we have? This is h, this is r, so this becomes h minus r in this right angle triangle. H minus r, and I can get a relation easily between h minus r and this. What about the volume of the cone? Volume of the cone is 1 by 3 pi r square. Instead of r, we have x square, and this is h, right? Altitude of the right circular cone of maximum volume that can be inscribed in this is this. Given the radius r of the sphere, I have one relation. What is that? R square is equal to h minus r whole square plus x square, right? And which of these can I eliminate? Can I eliminate x square? Can I eliminate h? I can eliminate x square very easily. This is pi by 3 h times x square is nothing but r square minus h minus r and its square. This is what you have, right? This can further be written as pi by 3 times h r square minus, what is this? Can we simplify this? Yes, we can simplify this before actually multiplying the h inside. Let it remain as it is. This becomes r square minus h square minus r square plus 2hr. This is what you get. R square gets cancelled, and what you're left with is pi by 3 times 2r h square minus h power 3 is what we are remaining with, right? This is what you get. This is the volume, okay? And once the volume has been written in terms of this parameter h, we can differentiate. D by dh of Vh, what is that? Pi by 3 is okay. This is equal to 4rh minus 3h square, okay? And the critical points will be h equals 0 will be the one of the points, h will come out common. Rest will be 4r minus 3h. So h will be equal to 4r by 3, and you can clearly observe that for h equals to 0, the height will be 0, therefore volume will be 0. This will be a minimum condition, and this will be for maximum condition. That's what you can see very easily, right? Although you can talk about the double derivative as well, that the double derivative will become 4r minus 6h, and this will be equal to negative for this one. Sorry, this will be negative, yeah. So there will be maximum at this particular point. So volume maximum occurs for Vmax for h equals 4r by 3, and this is what we wanted to prove, right or not? Yes, this is what we wanted to prove. That's the complete proof of this particular question. Question number 15th over here. The 16th question says that let f be a function defined on this closed interval a comma b such that f prime x is greater than 0 for all x belongs to this interval a comma b, okay? Derivative is greater than 0 means the function is increasing, strictly increasing. Then prove that the f is an increasing function on a comma b. Oh, the function is increasing. We are supposed to prove that it is increasing, okay? So the person does not want you to use the first derivative. The person wants you to use the actual definition of increasing, right? And can we use that? Yes. F be a function defined on a comma b such that f prime x is greater than 0 for all x belongs to a comma b. This is what we have, right? Okay. And prove that f is an increasing function on a comma b. And what's the definition of increasing function? That says if x1 is greater than x2 for some x1 comma x2 belong to this interval a comma b, this implies that f of x1 should be greater than f of x2. And not only this implies this, the converse is also true for this particular definition, right? This is the definition of increasing function, right? And how do we deal with this one? We can deal with this one with the help of a simple idea. And what is that simple idea? Can we use something called Rolle's theorem over here? Yes, maybe. We can use Rolle's or LMVD. LMVD is the better choice, right? LMVD can be used over here because derivative is not 0. So what we can do is take x1 comma x2 belongs to a comma b, okay? And for this x1 and x2 belongs to this interval, we can say that f of, let's say, x2 is greater than x1 as well, okay? So f of x2 minus f of x1 upon x2 minus x1 will be equal to f prime c for some c in this interval x1 and x2, right? For some c, c belongs to this interval x1 comma x2, okay? And this here is derivative is greater than 0. This implies that f of x2 minus f of x1 is greater than, this x2 minus x1 is a positive quantity, yes, this is greater than 0. This tells me that f of x2 is greater than f of x1, okay? Using the LMVD, this is what we have done. This is a simple approach of proving this one, and therefore that's the complete proof of this one, right? To then prove that f is an increasing function. This we are not using the derivative, we are doing it directly with the basics of LMVD, right? LMVD is something that we have covered in the previous chapter, right? So that's all that you have in this question over here. By the way, you can also deal with the converse of this particular expression in a similar manner, that let us take x1 x2 belongs to a comma b such that f of x1 is greater than f of x1 is less than f of x2 maybe, and after that you'll have this is positive, so this will go over there, and this will become x2 minus x1 will be positive after that, therefore x2 will be greater than x1. The converse can also be proved very easily, but I think this will suffice for now. That's the complete solution for this one. The 17th question says that show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is this. Height of cylinder of maximum volume inside a sphere. Okay, also find the maximum volume. So we are talking about a sphere which will look like a circle in 2D, and we are talking about a sphere. Okay, this is what a sphere will look like inside the, this is what a cylinder will look like inside a sphere. This is, okay, radius r of the sphere is this. This is the height of the cylinder, let's say, okay, and this here is small r, which is the radius of cylinder. Similarly, we can have this r, and we can have similar things over here, small r, and this. This becomes h by 2 actually. For the cylinder, this becomes h by 2, as you can clearly observe, right? The center of the cylinder and the center of sphere will coincide because this is a cylinder, right? This is what you have. Show that the height of the cylinder of maximum volume, V max, that's what we are supposed to deal with, that can be inscribed in a sphere of radius r is to prove height is equal to 2r upon root 3. That's our target, right? Okay, and what else? Also find the maximum volume. V max is equal to question mark, right? What is the relation between small r, capital R, and h by 2? You see that this is 90 degree. So r square plus h square by 4 is equal to capital R square. And what is the volume of sphere? This is pi r square h. Okay, and I can replace this r square by this particular term, pi h times capital R square minus h square by 4. Okay, this is pi r square h minus pi by 4 h power 3. Once you have written v in terms of h, you can differentiate v with respect to h. This becomes pi r square minus, this is 3 pi by 4 h square, right? And once you have done with this, then you can simply equate it to 0. Get that h square is equal to 4 r square upon 3. This is what you have. H square will be equal to 4 r square upon 3, which tells me h will be equal to 2r upon root 3. This is the critical point. Why not take the minus value? Because h is supposed to be positive. This is the height, right? So we're not considering the negative value. And if you observe, right, the critical point is 2r by root 3, and you have one value 0. So before 0, this will be smaller quantity, right? This will be smaller. Therefore, this will be overall positive, and here it will be negative. So increasing and decreasing function will tell me that you have a maxima at this particular point, right? So volume maximum at h equals 2r by root 3. This is what we wanted to prove, hence proved. The next thing that you are interested in finding that V max, right? So let's find the maximum volume. Let's find V max is equal to what? This is pi r square h, which is equal to this expression over here. And since small h is 2r upon root 3, we can easily find that as well. So this is pi into r square into h, which is 2r by root 3, minus pi by 4 times h power 3, which is 8r cube over 3 root 3. What is that equal to? This is pi r cube 2 by root 3, and you have this 2. So 2 by root 3 and 2 by 3 root 3 is what I have. Or you can say that you can take out 2 by root 3, pi r cube 2 by root 3 common, and what will remain is 1 minus 1 by 3. This is 2 by 3 actually. And from here I'll get V max is equal to what? V max will finally be equal to this expression. This is 2 by 3, this becomes 4 by 3 root 3, or which will become 4 root 3 by 9 times pi r power 3. This is what I'll get, and that is my answer for this question over here. That's the 17th question for us. The 18th question over here says that show that the height of the cylinder of greatest volume, which can be inscribed in a right circular cone of height h. Okay, this time you have a right circular cone, and inside that you have a cylinder. Okay, let's talk about this right circular cone. First of all, this is what it will look like, and then you have a cylinder inside it. Okay, this is a small cylinder which lies inside this. This is what you have. Let's say for the cylinder you have some things which you know certain things, and similarly for the cone you know certain things. Let's observe what do we have. Height of the cylinder of greatest volume, which can be inscribed in a volume of cylinder, has to be maximized. Okay, and height h, right circular cone of height h. The height of the right circular cone is given to be small h. Okay. Height of the cylinder is an important thing, and we are supposed to show that it is equal to something of height h, and semi-vertical angle alpha. Okay, semi-vertical angle is given to be alpha, is 1/3 that of the cone. Okay, you have to prove that this height is 1/3 that of the cone. Let's say this is y, and to prove y equals h by 3. This is one of the criteria. What else? And the greatest volume of the cylinder is this. We are supposed to find this greatest volume as well. Okay, now how will we deal with this question? So for cylinder and its volume, we need the radius of the cylinder as well, right? And if this is small r, let's call this small r, or for that matter, yes, let's call this small r, that is okay, cylinder, small r, and the height is y. Okay, and do we have some relation between this r and y in terms of alpha? Yes, alpha and h are known, so alpha and h are constants for us. We can easily find a relation between them. This triangle is a 90-degree triangle over here. This here is 90 degree. This is perpendicular. This is base for this alpha. So tan alpha is equal to perpendicular upon base. Base is this length, which is total h minus this y. This is what you have. What about the volume of cylinder? Volume of cylinder is equal to pi r square h. H is actually y over here, right? Let's observe that carefully. And once you're clear with this, you can actually replace this y by h minus y tan alpha. This becomes pi y times h minus y tan alpha and its square. Yes, r will be h minus y tan alpha. This is what you get. So pi tan square alpha will remain as it is. This becomes, this is actually equal to y times h minus y and its square. Okay. Once you have this, dv upon dy will be equal to what? The derivative of v with respect to y, pi tan square alpha, will remain as it is, and in the bracket you can apply the product rule. This will become h minus y whole square plus into the derivative of y, which is 1, plus y is a constant times 2 times h minus y and a minus 1, which is the derivative of h minus y. Applying the chain rule and the product rule simultaneously, you see h minus y coming out, pi times tan square alpha times h minus y, and what remains is h minus y minus 2y, right? Please observe this. This is h minus 3y. So pi tan square alpha is all okay, h minus y is okay. This is h minus 3y. The critical points for y are h and h by 3. Okay. And can you analyze the values? Yes. At these critical points, h by 3, h. Okay. Y at max can be h. So this is the maximum value and least value is 0 over here. Beyond h by 3, or for that matter beyond h, what do you have? This is negative, this is also negative. So negative, negative will actually be positive. We don't require this range. Before my h, we have, let us say, h by 2. So this will be positive, this will be negative. So overall it will be negative. Before h by 3, let's pick up 0. So this is positive, this is also positive, this will be overall positive. So function is increasing, then decreasing, and then increasing. The maximum value occurs at this. We are interested in the maximum value, yes. Therefore, V max at h equals, sorry, h at y equals h by 3. Y equals h by 3. Now that's the first part and hence proved. The next part is to find the V max. The next part is to find that V max. And can we find that V max over there? Yes. V max will be equal to pi r square y. Y is equal to h by 3. That's known. What is r square? R square is h minus y whole square tan square alpha. So we'll deal with this one. Right? Pi times y is h by 3 times h minus h by 3, which is 2h by 3 whole square, will be 4h square by 9 times tan square alpha. Okay, therefore V max is nothing but, from there you can get V max as well. And what is that? This is 4 by 27 first of all, and you have h power 3 tan square alpha. Okay, and is this what you wanted to prove? Yes, there's a pi as well, don't miss that pi. 4 pi by 27 h cube tan square alpha. That's the complete proof of this question over here. That's the complete solution and the final proof of this question over here. Let's talk about the 19th question, which says that a cylindrical tank of radius 10 meter is being filled with wheat at the rate of 314 cubic meter per hour. That's interesting. Then the depth of the wheat is increasing at the rate of, okay, cylindrical tank of radius 10 meter. We have a cylindrical tank of radius 10 meter okay, this radius, let's call this radius 10 meter, okay, is being filled with wheat at the rate of 314 cubic meter per hour. Wheat is being poured in it, okay. So the rate of change of volume, basically volume of wheat in this is dV by dt is actually equal to 314 meter cube per hour. This is what you have, right? Then the depth of the wheat is increasing at the rate of depth. Let us consider this, the depth, this is y, let us say, and we are interested in dy by dt, which is question mark. This is the important thing that we are interested in, dy by dt. Now what is dy by dt equal to? Let's take a look at this one. So observe, can we write the volume in terms of, let us say, for a cylinder, we can easily write the volume will be pi r square times y, which is the height, yes, and dV by dt will be equal to pi r square times dy by dt, which is very simple, yes, and I can handle this easily now. This is 314 and units are consistent, right? So this will be in meter per hour, we can handle that. This is pi, okay, and this is pi, let us say this is pi, r is 10, so this is 10 square times dy by dt. Please observe, pi can be approximated as 3.14. There's no pi in this question, right? So this is 3.14 times 100 is 314. This goes with this. So dy by dt is actually equal to 1. And the unit will be meter per hour. This is what you have, 1 meter per hour. And which of these answers is correct? The correct answer is option A over here. That's the final answer for this question. The 20th question says that the slope of tangent to the curve this at the point 2 comma minus 1 is. We are interested in dy by dx, that's it. So dy by dx is equal to question mark. But then we are given a point 2 comma minus 1. Now x is equal to 2, y equals to minus 1. That implies that we should be able to eliminate t or maybe get the value of t, right? Because dy by dx for us will come in terms of t, right? So it is given that t square plus 3t minus 8 is equal to 2, which tells me t square plus 3t minus 10 is equal to 0. That tells me t plus 5 t minus 2. Factorizing by splitting the middle term, this will be equal to this, t equals 2 or minus 5. This is the value, right? T equals 2 or t equals minus 5. What about the next one? 2t square minus 2t minus 5 is equal to minus 1. That tells me that 2t square minus 2t minus 5 minus 4 will be 0. Or you can say that dividing by 2, this will be t square minus t minus 2 is equal to 0. This tells me t minus 2, t plus 1 is equal to 0. T is equal to minus 1 or 2. And which of these values satisfies both these conditions? You can observe that t is equal to 2 is the result that we are interested in. For t is equal to 2, we are supposed to find dy by dx, okay? So t is equal to 2 is the important thing. That is something which you should identify first. dy by dx will be equal to dy upon dt whole divided by dx upon dt. And what is that equal to? dy upon dt is 4t minus 2. This is 4t minus 2. What is this? This is 2t plus 3. That's what you have. 2 times 2 is 4 minus 2 and this is 2t plus 3. This becomes equal to what? Putting t is equal to 2, dy by dx will be equal to what? This is 4 times 2 minus 2 over 2 times 2 plus 3, which is 8 minus 2 is 6 upon 4 plus 3 is 7. And yes, that is the correct answer for this question. That is option B is the correct answer for this one over here, as you can see behind me. Question number 21 says that the line y is equal to mx plus 1 is a tangent to the curve this if the value of m is what? That's the question in front of you. Okay, let's try to take a look at this one. So for y square is equal to 4x, let's try to write the equation of a tangent line. Okay, having slope m. Okay, and what will we do? This is 2y, y prime is equal to 4. Okay, and this tells me that y prime will be equal to 2 upon y. This is what we have. Slope is this. So any point on this curve will be, let's say, p h comma k, and tangent line will be y minus k is equal to m, that is the slope, which is, okay, you can write it as m times k x minus h. This is what you'll be able to write it as. And you have a relation between h and k, yes. What is that relation? 4h is equal to k square. That's a relation that we already have between these two conditions, these two coordinates of the point, because the point lies on y square is equal to 4x, right? So this is what we already know, and this is the equation of tangent, wherein what you'll have is m can be replaced by this 2 upon k. So let's replace 1 minus k is equal to 2 upon k, and then we'll compare with that. This is x minus h. H is k square upon 4. Now you see the only variable remaining over here is k. Okay, and what else? This is ky minus k square is equal to 2x minus k square by 2. That's what you have. So ky is equal to 2x and plus k square minus this is k square by 2, and this further becomes y is equal to 2 upon k x and plus k by 2. This is what I get, right? This is what I get. And on comparison with that line y is equal to mx plus 1, what do I see? What do I see? That k by 2 is equal to 1 and 2 by k is equal to m, and therefore this is also equal to 1. That's the reciprocal of k by 2. This is also equal to 1. Therefore the value of m that is required is this option A. That's the correct answer for this question, and that's the complete solution that you require for this question. Question number 22 says the normal at the point 1, 1 on the curve this is. Okay, we can easily find that normal. 2y plus x square is equal to 3. This tells me 2y prime. Y prime is the derivative of y with respect to x, plus 2x is equal to 0. This tells me y prime is equal to minus x. Okay, so point for normal is known, that is 1 comma 1. It is already given that it is 1 comma 1, and slope for, we are talking about the normal, right? For the slope you will have, let's find the slope of tangent first. Y prime at 1 comma 1 will be equal to minus 1, and this is the negative reciprocal of this. This becomes plus 1, right? Point is known, slope is known, therefore y minus 1 is equal to 1 times x minus 1 is what you get, which implies y minus 1 is equal to x minus 1, which tells me y is equal to x is the line you are looking forward to. This is the equation of normal, and which is this line. This is x minus y equal to 0. That's the correct answer, option B over here in this question. This is question number 22. That's the complete solution of this question, a pretty simple one. 23rd question says that the normal to the curve this passing through 1 comma 2. Mind you, passing through 1 comma 2. Now 1 comma 2 may or may not be a point lying on this. Let's say 1 comma 2. No, it is not a point lying on this. So we'll first write the equation of normal at some point h comma k on this, and then we'll pass it through 1 comma 2 and get the equation, right? So for x square is equal to 4y. By the way, this question is, we have solved this kind of a question in the exercise as well, right? We used capital X and capital Y there. Let's use h comma k for the point over here. Point P is h comma k, let's say. And then what do we have? We have 2x is equal to 4y prime, which tells me that y prime is equal to x by 2. And this will imply that slope y prime for this particular point will be h by 2. Okay, that's the slope of tangent. Okay, slope of normal will be negative reciprocal of this. Point is h comma k, so y minus k times negative reciprocal minus 2 by h, x minus h is what we require. Okay, this is what we are interested in. And what is this further equal to? This tells me that this particular line further passes through the point 1 comma 2. That's interesting, but one important thing which remains is that h comma k lies on this, implies h square is equal to 4k. So let's eliminate one of the variables. Let's eliminate k from here. Y minus, this is h square upon 4 is equal to minus 2x upon h and plus 2. This is what you have, right? If this normal passes through the point 1 comma 2, then if this normal passes through this point, then what do you get? 2 minus h square upon 4 is equal to minus 2 upon h plus 2. And can you solve for the value of h? Yes. What do you get? This tells me h power 3 is equal to 8. And this further tells me h equals 2. Once you know that h equals 2, can you also find the value of k? Therefore, k is equal to h square upon 4, which tells me k equals 1. I know the point, and I can easily write the equation of the normal with the help of this. Y minus 1 is equal to minus 2 by 2 times x minus 2. That's what you have, right? And that becomes y minus 1 is equal to minus x plus 2. That tells me x plus y is equal to 3. That's what you have. X plus y equals 3. That's the equation. That's the required equation on the normal. Question number 2. Similar question we have solved in the exercises, during the exercises as well. That's the final answer for this question over here. Question number 24 says the points on the curve 9y square is equal to x cube, where the normal to the curve makes equal intercepts with the axis. Now that's an interesting thing. What does it say? Makes equal intercepts with the axis. Equal intercepts would imply that equal intercepts with sign, either plus plus or minus minus. And what you can observe is, if this length is equal to this length, this angle is 45 degree, this angle will be 135 degree, tan 135 degree, which is the slope, will be equal to minus 1. Slope of this line is minus 1. This is the important thing that you observe for equal intercepts, for the case of equal intercepts. Right. So the points on the curve, this where the normal to the curve makes equal intercepts, that is the slope equals minus 1 of the normal. Mind you, m of slope of normal is equal to minus 1 implies slope of tangent is equal to minus 1 upon this negative reciprocal of this, which is plus 1. This is what we are interested in. So 9y square is equal to x power 3, which tells me 18y y prime is equal to 3x square. This tells me y prime is equal to 3 upon 18 x square upon y is what we are interested in. And that slope equals y equals 1 is what we are interested in. After that we'll get the point, right? So the point h comma k, if point is h comma k, then we know that 3 upon 18 is 1 by 6. What do we have is 1 by 6 times h square upon k is equal to 1, which tells me h square is equal to 6k. This also tells me that if the point is h comma k, then 9k square will be equal to h power 3. Those are two things. There are two equations, 1 and 2. Let's solve the two equations to get the values of h and k. K can be substituted over here. Therefore, 9 times h square by 6, h power 4 by 36 is equal to h power 3. This becomes 4. Okay. H power 3 equals 0 or h equals 4 is what I get. This tells me h equals 0 or h equals 4. We are interested in that h equals 4, right? H cube, h equals 4. H equals to 4 further tells me that what will be the value of k? K will be equal to 4 square 16 by 6. K will be equal to 16 by 6. That's what you'll have. Is it? Please check that. Or we'll use the value. You will use the curve actually. And where does that take me? Right? Let's observe. This is h, which is 4 cube. Okay. This tells me that k square will be equal to what? K square will be h cube upon 9. Now what is that equal to? H power 3, which is 4 power 3, 64 upon 9. And k will be equal to plus minus 8 upon 3. That's what I get. Plus or minus 8 upon 3 is what I'll be getting in this question over here. And k is equal to plus minus 8 upon 3. Can we check this value as well, right? So 4 comma plus minus 8 by 3, that seems to be option A, is it? Yes, that seems to be option A, and option A seems to be the correct answer over here. But let's check the slope as well. Okay, these people may have taken this m is equal to minus 1 as well, may have taken that, because for this kind of a line, the magnitude of the intercepts are same, right? The intercepts are not equal, the magnitude, that's without sign, they are same. When you remove the sign, the modulus of the intercepts are exactly same. So I hope they have not taken that. By the way, we are getting k is equal to plus minus 8 by 3, which is not okay for this statement over here, right? Can you please observe? This is 16 upon 6, which is 8 by 3. So the actual value of k that you require is actually 8 by 3, not minus 8 by 3. For minus 8 by 3, you will get this equals to minus 1. Therefore, this will be plus 1. Yes, they have made a mistake over there. And they have considered, the NCERT people, they have considered that equal intercepts implies, okay, you're not worried about the sign and all. You're only worried about the magnitudes. But that's not the actual thing, right? The JEE people have a concern in that. And in such a case scenario, for the NCERT, we can say that equal intercepts means this and this both. But in general, when you get the question in the JEE examination or any other examination for that matter, be very careful. By the way, this is from the point of view of NCERT, if this is controversial, people will avoid this kind of thing, but in case you get such kind of question, you will require some kind of clarity and be very aware that whatever you are doing is something after understanding only, right? So take care of that. Here 4 comma 8 by 3 is not present, so the best possible choice is this answer, 4 comma plus minus 8 by 3. That's what we have chosen in this question. That is the correct answer for this question over here. With this, we come to the conclusion of this miscellaneous exercise from the chapter application of derivatives. That's the end of this sweet, simple, easy exercise as compared to the others, because the others were quite difficult. In this chapter, others were pretty long as well. Other exercises were, some exercises were pretty long. Miscellaneous exercise had mixed questions and relatively easier, as I would say. But then you can revise all the concepts of the chapters with this miscellaneous exercise and the solutions of the questions. Right? Till the next session, all the best.